let's try a couple more examples here. First thing we're going to do is we're going to move over this 24x. And I want to make sure, too, that I have all of my x's, and that if I don't, I'll have a 0x. And it looks like I do. I've got a 4, 3, 2. Here's the 1 that I'll move over. So I'm going to write this out. x4 plus 6x cubed plus x squared. And now I'm going to move over that 24x. I'm going to subtract it over. So I'm going to subtract over the 24x plus 16 is 0. So I'm looking at the 16, and I'm going to try a bunch of numbers. I'm going to try plus or minus 1, 16, 2, and 8, and then 4. What I'm going to do here is I'm not actually going to plug the numbers in. I think the faster way to go about this is to just do some trial and error this way. So I'm going to write down 1, 6, 1, negative 24, and 16. Bring this down. And so now I'm just going to be trying a bunch of numbers just to see if it works. So I'm going to first try negative 1. So 1 times negative 1 is negative 1. That should be a 5. That should be a negative 5, which is a negative 4, which is a positive 5, which is a negative 19, which is a positive 19, which is definitely not going to get me 0. So I'll just erase that. Try it again. Let's try positive 1. So 1 times 1 is 1. 7. 7 times 1, 7. 8. 8 times 1, there. That's going to be a negative 16. Hey, that works. That gets me a 0. Now what I wanted to point out here is that negative 1 did not work. And that means that it's not going to work for all of these. But anytime you do have a success, it could be another success, meaning 1 could work again. So I'm going to try 1 here. Again, it did work. There's no reason why it couldn't work again. So 1 times 1 is 1. 7, 1, 8. 8 times 1 is 8. 8 plus 8, 16. 16 times 1, 16. Sure enough, it works. Now this was an x4. Every time we divide, we are dividing out an x essentially. So we did one division, that would get us to an x cubed. We did another division, which brings us to an x squared. And once we always get to an x squared, we can factor it or use a quadratic formula or something like that. So I'm not going to do this anymore. I'm going to just go right on to factoring. So this is going to be a 1x squared plus an 8x plus a 16 is equal to 0. I don't need to write the 1 here. Now both of these here, I can't draw that. These are going to be x minus 1s because putting in a 1 made it 0, and we got remainder 0, we got remainder 0. So both of these worked. I'm going to square it. So we have 2 of our factors already. X minus 1, 1 worked, and x minus 1, 1 also worked. And now we have this, and we can factor this. X, 4, 4. One diagonal is 4x, the other is 4x, for a total of 8x. So I know I've done this right. X minus 1 squared, x minus 4 squared equals 0. So this would be fully factored, by the way. So we would leave it like this if the question just asked us to factor it. But it asked us to solve. So what would make this thing 0? 1. And what would make this 0 would be a 4. And these are both doubles. So if we were drawing this, it would bounce back once it hit the x-axis. Or you could say it has multiplicity of 2. So both of these are doubles. Not that it really matters for us. We're not drawing anything right now. But it is just worth noting. So we were pretty lucky on this one because we tried negative 1 and it didn't work, but then we tried 1 and that it worked, and then I decided, well, let's just try it again, and it also happened to work. That's not always the case, but this is an example where 1 ended up working twice. So let's take a look at E here. Okay, so let's maybe start by bringing everything over to the left side. I notice here that there is a x to the 4 missing. I have an x to the 5, and then I go right to x3. So I'm actually going to add that x to the 4 in, but I will keep it as a 0. So then I got the 15, then I got the -5, and then I'm going to add the 15x over, and then I'm going to add the 9 over equal to 0. Now, I am going to, because this is an x5, I'm going to have to do some polynomial long division. I'm going to have to do it 3 times to get me from an x5 to an x4 to an x3 to an x squared. And then once I'm at x squared, I can factor this again. So I'm going to start here. I'll write this out. 4, 0, -15, -5, +15, and +9. This will be carried down as a 4. So what am I going to try? So I'm looking at 9 plus or minus 1, 3, and 9. Those are all factors. Now, one thing that's worth noting in all of this is, and I haven't actually done it, is if the number in front is not 1, we actually have to include it as a possibility. So what multiplies to 4 is 1, 2, and 4. And so if I was actually going to list all of these out, I'd have plus or minus 1, 3, and 9 all over 1. And then I'd have 1, 3, and 9 all over 2. And then I'd have 1, 3, and 9 all over 4. Now I'm not going to have the over 1s. I'm going to erase those. But these are technically all the different possibilities that we could have. I'd obviously start choosing these first. So I can try plus or minus 1, 3, 9. Let's just try, for the heck of it, a 3, just to see. So 4 times 3 is 12. That's 12. That is 36, which is 21, which is 63, which then would be 58, which would be 170. This does not look at all like I'm getting anywhere close to 0. So 3, obviously a bad option. Can't try 2, so guess I'm going to try 1. I'll try -1, -4, +4. So this is going to be -11, which would be 6. So -6, which would be 9. And then -9. Wow, did that actually work? It looks like it did. So -1 worked. Okay, so I know 3 doesn't work. I'm not going to try it. I could try just a 1 and see if it works. So let's try 1 now. 4. So that's going to give me 0. 0 times 1 is 0. That's a -11. That's also a -11, which gives me a -5. -5, which gets me a 4. So it doesn't work. So if 1 doesn't work now, it's never going to work. 3 didn't work, so it's never going to work. There's no reason why I can't, again, try -1. -1 worked at the beginning. It could work again, so let's try it. 4 times -1 is -4. That gets me -8, which gets me +8. If I add those, I get -3. My diagonals will be +3, which would get me a 9 times -1 is -9, and that gives me a 0. So remember, I had an x5. I need to do this 3 times to get to an x squared. So 1 didn't work. It's never going to work. 3 didn't work. It's never going to work. -1 worked twice. I mean, what the heck? Let's just do it one more time. So I have a -4. That gets me a -12, which is a +12, which gets me a 9, which is a -9, which gets me a 0. Wow, so -1 worked 3 times. So I've got these. So I've got an x plus 1. -1 works. -1 would work to make this thing 0, and I have 3 of them. And then I have an x squared function here. So I have a 4x squared minus 12x plus 9 equals 0. This is hopefully factorable. I guess I'll try 2x. I'll try 3. I need positive 9, but the inside's negative, so I'll make them both negative. So I have a negative 6 and a negative 6, which get me a negative 12. So it looks like it's good. So I have an x plus 1 cubed and a 2x minus 3 squared equals 0. So if I wanted it fully factored, I would just do this. But it's actually asking for an answer here for us to solve. So negative 1 will work. And then this would be a 3 over 2. If you didn't know how I did that, by the way, you could just go, what would make the bracket 0? Add 3 to the other side, and then divide both sides by 2. So 3 over 2. So those are our answers. Negative 1 here has a multiplicity of 3, and 3 over 2 has a multiplicity of 2. But that's a strange example where negative 1 ends up working 3 different times.